Ladies and gentlemen, today we begin polar coordinates, alright? Now, so far in our class, we've talked about graphing rectangular coordinates. Okay, that's where you have an X and that's where you have a Y. And then we've also talked about graphing on the unit circle, alright? Polar coordinates is pretty much graphing on the unit circle with just a little bit more added in, okay? So first, look right here if I can get that. Look right here, r comma theta, okay? So that is called a polar point, okay? So in a rectangular point, you have an X and you have a Y. So in a rectangular point, you have some X and you have, sorry, I'm really slow at this, and you have some Y, okay? In a polar point, you have an R and you have a theta, okay? Now, the unit circle is basically just graphing polar, but where R is always 1. So what we're going to start doing is we're going to start seeing what happens if R is something other than 1, okay? So you're going to really need to remember how we graphed theta. So first off, remember that positive theta was going counterclockwise, negative theta was going clockwise, okay? That's an important aspect to remember, okay? So let's go ahead and dive into a problem here. Let's say we're plotting the point -3, 3 pi over 4. Alright, so -3. Okay, that's our R value. R is called a directed distance, okay? So we want to go -3 in the, we're going to go -3. That's the directed distance we want to go. So an easy way to look at that, see how polar is basically a bunch of circles, okay? Is basically see that this is a circle with radius 1, okay? So the distance from here to here is 1. This is a circle with radius 2. So the distance from here to here is 2. This third circle is a radius 3. So the distance from here to here is 3. However, I want it to be the negative way. So the positive way would have been over here. So the negative way is going to be over here. So we know a -3 means I'm on the third circle. And the negative means that this is my starting spot. Okay? Now, I need to go 3 pi over 4. So now you just have to ask yourself, what is 3 pi over 4 from this point right here? Well, you can look over here, pretend you're on the positive side again. Pretend that we started over here for a second. Pi over 4 would be right there, right? Just pi over 4, and then another pi over 4, and then a third pi over 4. So 3 pi over 4 lands right here. Carry that same thought process down to right here. So -3, we want to go pi over 4. So we've gone pi over 4. Now we want to go another pi over 4. We've got another pi over 4. Now we want to go last pi over 4. Boom. This is where we'd land up. So really, in a normal sense, we would land at 3, 7 pi over 4. But we could also say that this point is -3, 3 pi over 4. Alright, so this is where we'd land up. 1, 2, 3, 7 pi over 4. Bada bing, bada boom. Okay, let's do this next one. 5, -pi over 2. So 5. So radius 1, radius 2, radius 3, radius 4, radius 5. So that's where I start. And then I want to go -pi over 2. And you should know -pi over 2 would just be right down here. So what would be another way of stating this point? One way of saying the location of this point is 5, -pi over 2. But what would be another way of saying this point? Well, I could also think about it as being 5, 3 pi over 2. So that would be another way that I could say this point, okay? Or you could even say -5, so that would start us right here, +pi over 2. So that would carry us down to right here. Alright, let's do one more together. -2, -11 pi over 6. Okay, so -1, -2. So I start right here on this second circle on the left side. And I need to go -11 pi over 6. Okay, so let's think about that. How do I go -11 pi over 6? Well, think about it if you were to find 11 pi over 6 in the positive direction. So that would start right here at 2, and we'd go around to 11 pi over 6. Do you notice how far from this horizontal you are? 1, 2 lines. You can cheat and do the same thing from over here. -2, you're going to go around and just make sure you're 2 lines away. So bam, you end up at 5 pi over 6. Sorry, I'm really bad at making points. But that's where you're going to land. So there you go. Alright, so that's how you can do these first 3. Alright, let's look at this one. Give 3 equivalent points for each of the following. Okay, so I kind of touched on that a second ago. But what it wants us to do is just basically think of 3 other ways I could state the same point to land on the same location. So first, you do not have to graph it, But let's graph it just so that we can kind of get an idea of where it's going to land. Okay, 5, 2 pi. Where is that going to land? Let's see. Radius 1, radius 2, radius 3, radius 4, radius 5. 2 pi, I go around the circle one time. Bam. All right, so there I am. So now it wants us to think of 3 other ways we can say this. Okay, well, let's ask ourselves, did we move up or down at all, really? No. So we could also say that this is the point in polar 5, 0. That's a 5. That was a terrible 5. Let me redo that 5. Okay, just pretend that's a 5. 5, 0. Okay, so that's one way I can say it. Now, let's think about 2 other ways. Well, the new thing we've kind of added in today, as that this is different from a unit circle, is the fact that we could have negative. We could start over here on the negative side. So what if we started at -5? And how would I get here? What would be the angle I would need to go to get here? Well, that would just be half a circle, right? Well, what's half a circle in angular idea? Pi. So I could just say 5, pi. 5, pi. Okay, now let's think about that. What's another way I could get one? What's another way I could get one? Let's see. I could start it. Oh, that should be -5. Sorry. I could say -5 again. And then maybe rather than going a positive angular direction, I could go a negative. So what would be the negative angular direction to get here? -pi. And so there you go. You got yourself 3 points that would all land at the same spot. That's the whole idea. We did this before. We just did it with, we were just dealing with the unit circle, but it's the same idea. We're basically just kind of trying to come up with points that will land at the same spot as our original point. All right, let's do number 7 together. 1, -7 pi over 6. All right, so 1, oh, hold on, I didn't erase that point. So let me do a different color here. Let's do brown. 1, -7 pi over 6. Okay, so first off, I got to think about where is 7 pi over 6 going to fall? Okay, well, I know that positively 7 pi over 6 is going to fall right here. Okay, well, let's just see how close to this line does that put us. So first off, you'll notice we went half a circle, and then we went 2 more lines. So then we could follow that same idea. We could go half a circle, and then 2 more lines. So that would put us right there. Okay, so now let's think about how can I get some other points? Well, one, it should be fairly obvious. That couldn't I have said positive 1, 5 pi over 6? So I could have said positive 1, 5 pi over 6. 5 pi over 6. Just pretend I write better. Okay, so now let's start thinking. I've done positive 1, so let's try a -1. What if... Sorry, that's just so bad. I have to erase that real fast. So -1, and then, so you guys start thinking, what is the angular direction if I want to go positively around the circle right here? Well, think about if you were going to do it, see, so here's -1 right here. And I want to go around the circle positively and land right back there. What is that angle? Well, think about it if you were to do that kind of idea. It's 1, 2 from being a whole circle, right? It's 2 lines from being a whole circle. So what if you were to do it from positive 1, you were going to go 2 lines? Where would you land? At 11 pi over 6, right? So that's that same idea. You're really making an 11 pi over 6 angle. So -1, 11 pi divided by 6. All right, let's come up with one more. -1, this time, let's do a negative angle. What is that negative angle right there? Just pi over 6. Hopefully you see that if you do positive 1 to go pi over 6, it would just be 1, 2. So here's that same idea, 1, 2. So pi over 6. Ta-da! You have 3 more points. Okay? Real quickly, I'm going to help you remember how to do a problem like number 11. It says, eliminate the parameter and write the corresponding rectangular equation. So this is parametric. 11 and 12 are both parametric review questions. And what you have to do is you have to solve for t on one of these equations and plug in for the other one. So I'm going to solve for t here on the x. So to solve for t here on the x, I would subtract 3. So I'd get x minus 3 is equal to t. All right? So then I have to plug that in for the y equation. So I replace t with x minus 3. So I'd say y equals x minus 3 raised to the second power. Now, the thing is that I know you guys just took a quiz on this, and you saw that it wanted you to actually square it out. So that's y equals, oh, I'm kind of moving out of the screen here. So that's y, let's just shrink this real fast. That's y equals x minus 3 times x minus 3. Okay. And so then you're going to do x times x times negative 3 times x, negative 3 times negative 3. I'll leave this as an exercise to you to pursue, but I can tell you the answer is y equals x squared minus 6x plus 9. All right, and you do kind of want to be able to get yourself to this final answer, because that is how the multiple choice is going to end up. I don't mind if you leave it like this, but on multiple choice questions, I'm going to ask it to you. I'm going to give you an answer choice like this. All right, so just be aware of that. Okay, good luck in the rest of this homework. Have a great day.